All right, module 7.2, finding complex solutions of polynomial equations, day 2. So today we're going to talk about the irrational root theorem and the complex root theorem. Basically what it says is if you have a irrational root, then you also have its counterpart, the negative. Same with the complex. If you have the positive, then you also have the negative. They may only give you one, but you need to know they come in pairs. Today we're going to focus on writing a polynomial function from the zeros. So we're going to go backwards of what we did yesterday. So this first problem that we're going to work on is pretty basic, and we're going to write a polynomial function with least degree and a leading coefficient of 1 that has the given 0. So we're going to start our first one. The zeros that we were given is it's 2 and negative 3. So they've given us the answer, and they're asking us to build up the polynomial. Based on that fundamental theorem of algebra, since I have two answers, that means my power of my polynomial should be squared. So we're going to start. I know my answer is x equals 2 and x equals negative 3. Now I need to go backwards. I need to put this back to what it would have been before I used the zero product property, which means x minus 2 equals 0 and x plus 3 equals 0. We're going to move them to the other side with the x, and I'm going to put them back in the parentheses. So x minus 2, x plus 3, and then I'm going to FOIL it back together. So x times x is x squared, x times the 3 is 3x, negative 2 times x is negative 2x, negative 2 times 3 is negative 6. I am going to put an f of x out here in front, combine my like terms, and I have built my polynomial function from the answers. So we're just going in the backwards motion. I had two answers, I have a squared, I'm good to go. So we're going to look at some where we don't have just our regular values, we have some complex solutions. We're still going to start the same way. X equals 5, x equals 3 plus 2 square roots of 7. But remember, this one also has a counterpart. X equals 3 minus 2 square roots of 7. So now we're going to multiply these together. My words of wisdom. Multiply the radical ones together first, your complex ones first, then multiply by the non. Make your life easy. But before we get there, we need to move them back over. Whoops. So that would be x minus 5 equals 0. In this case, I have to subtract 3 and subtract 2 square roots of 7. So this would be x minus 3 minus 2 square roots of 7 equals 0. But over here, I'd subtract the 3, but I'd add the 2 square roots of 7. So I'd get x minus 3 plus 2 square roots of 7 equals 0. Now, putting them back into the parentheses, I get x minus 5, x minus 3 minus 2 square roots of 7, and x minus 3 plus 2 square roots of 7. Now, multiplying this little beast. You could use the distributive property. If it's me, though, I'm going to use this little box method. So x minus 3 minus 2 square roots of 7. And we're going to fill it in. And I just realized you guys can't quite see that. So I'm going to slide the board over just a little. We're going to use the box method to multiply those together. X times x is x squared. Negative 3 times x, that's negative 3x. Negative 2x square roots of 7. Here I get negative 3x. Negative 3 times negative 3 is 9. And then negative 2 times negative 3, that's 6 square roots of 7. And then the last one, that's negative 2x square roots of 7. And let's see. Oh, wait, sorry. This should be a plus 2x because remember it's a positive there. My mistake. Here, this would be a negative 6 square roots of 7. And then negative times a positive 2, that's a negative 4. And the square root of 7 times the square root of 7 is the square root of 49, which we will simplify in just a moment. Going back, when we start looking at this, I have an x squared, negative 6x, and then look, the negative 2x squared is 7, and a positive 2x squared is 7, they cancel. Negative 6 squared is 7, and positive 6 squared is 7, cancel. The square root of 49 is really just 7, and negative 4 times negative 7 is negative 28. So I'm going to combine 9 minus 28 gives me negative 19. And notice, I don't have any square roots to deal with. They should drop out, peoples. And I still have that x minus 5 there. Now, I can use the box method again, or I can distribute. I'm going to distribute on this one, but feel free to use the box method. So x times x cubed, or x squared is x cubed. X times negative 6x, negative 6x squared. And then negative 19x. So I multiplied everything over here by the x. Now I'm going to multiply it by the negative 5. That gives me negative 5x squared, and I'm lining it up. That is a positive 30x, and that is a positive, let's see, that's 95. So I have x cubed minus 11x squared plus 11x plus 95. And this is my f of x, and that's my function. Now, I want to look at it. I had 1, 2, 3 answers, and I have a cubic power. So I'm doing really good with this. Now, the last one that we have, our last example, quite lengthy, but that's okay. You guys are up for a challenge, right? So looking at this, I have an answer of 2, I have an answer of 3, and an answer of 1 minus I. Well, that means x is 2, x is 3, x equals 1 minus I, but that also means x equals 1 plus I, because they come in pairs. Putting them back into the zero product, that's x minus 2 equals 0, x minus 3 equals 0. When I subtract and then I add, that's x minus 1 plus 1 equals 0, and here, minus the 1 and minus the I, that's x minus 1 minus I equals 0. So these two multiplying together are going to be easy. These two, not so easy. So we're going to kind of do this as two sets. Let's start with the easy set first. This is just FOIL. I get x squared minus 2x minus 3x plus 6. So x squared minus 5x plus 6. Now, I got to get the answer on the other side. To do this one, I'm going to use that box. All right. X times x gives me an x squared. Negative 1 times x is negative x. This gives me negative xi. X times negative 1 is negative x. Negative 1 times negative 1 is 1. Negative I times negative 1 is I. X times I is xi. Negative 1 times I is negative 1i. Negative I times positive I is negative I squared. Now, I want you to check things out. We've got an x squared, negative x, but this, the xi and negative xi, they're going to cancel. Positive I and negative I, they're going to cancel. Remember, negative, or I squared is negative 1, but I have a negative on the outside, so negative times a negative makes that a positive 1. So when I kind of clean this up, I get x squared minus 2x. 1 plus 1 is plus 1. And I need to go through and do the same thing with these. Let's set up the box. If you don't like the box, don't have to use it. But I think it's a great way to keep your work organized, keep you looking and feeling sane, like you're not losing your sanity. All right. That's x to the 4th. Here, let's do it in pink. Be creative. Another color. X squared. This is negative 5x cubed. That's 6x squared. Negative 2x cubed. 10x squared. Negative 12x. X squared. negative 5x plus 6. Now, looking at combining, whoops, I wrote a 2 there, and it should be x to the 4th. We're going to combine our like terms to get our final answer. So we have x to the 4th. Negative 5x cubed minus 2x cubed, that's minus 7x cubed. We have 6x squared, 10x squared, and x squared. They're all positive, so positive 17x squared. Negative 12 minus 5 is a negative 17x, and a plus 6f of x equals, and here is our equation built from the zeros. We had 1, 2, 3, 4 answers, and I have a power of 4. So we are doing great and wonderful. This is how we use our theorems. It's important to remember anything with an I and a radical is going to come in pairs. There will be 2 of them. When all is said and done, even though they're answers, they should not have any radicals or any i's in the equations when you are finished writing them.